My name is Bevan Watson. I'm a partner with McKinsey based in Sydney, as Blaney said. And in this session, I want to share my experiences on what it takes to successfully deliver green projects in the mining sector. And just by way of a little bit of background, partner based here in Sydney, been with McKinsey for about 10 years. I lead our capital excellence practice in Australia, and my background is as a civil engineer and have some industry experience working for Lend-Lease prior to that. But today we're talking about what it takes to efficiently deliver green capital projects in the mining sector. And really this is about green projects, but the story here and a lot of what it takes is similar for all capital projects. So really the story starts with the huge amount of CapEx needed in the mining sector over the next 10 years. It's about $5 trillion US that's going to need to be spent by 2035. And where's that coming from? That's coming from a few different areas. There's capital that's going to be spent on ramping up the supply of critical minerals. There's capital that's going to be spent compensating for the depletion and grade erosion in existing mines, and then there's capital that's going to be spent to meet energy transition targets. And maybe just a little bit more color on that last one on the energy transition targets. There's a lot of energy that's going to be needed in order to power this. Just looking at the growth alone, not even decarbonizing, we're estimating 270 gigawatts needed for that by 2035. And then the decarbonization side is going to need another 1,100 gigawatts. So there's a lot of growth that's needed. A bit of the problem in this and in this sort of growth is that it's going to be challenging. There's even holding steady to not even growing, holding steady on the amount of capex would be difficult. And this chart starts to a little bit show why, and it looks at the relative productivity of construction versus other sectors in the industry over the last 9 years. And what you can see on this is on the red line on the top shows manufacturing productivity. So that's grown by 17% over this time frame. Pretty good performance. You look at the overall economy in the blue line in the middle, that's grown by 10%. Construction is the line at the bottom. That's decreased by 1%. So not a very good result on the construction front. And things have gotten even harder over the last 3 or 4 years, as many of us know, right? There's been significant cost escalation over this time frame. There's skilled labor shortages. And then when you start trying to do this in the green CapEx space, things are even harder. It's a crowded market. There's cost pressure on trying to deliver these green projects. The supply chain is constrained, the technology is new, and often the contractors don't want to take risks on these types of new green projects. And, it's not unique to mining. Move the mics closer together, and then it'll be better. Okay, great. It's not unique to mining. There's a common set of frustrations that we see across the entire construction ecosystem across all industries. So, there's one around people often saying there's low transparency. We get regular surprises, and the result is that as a management, as an owner's team, we're always in firefighting mode. There's limited innovation, and there's a resistance to design changes. And, frankly, it's a little bit understandable on the part of the contractors on this. Their reality is that they're working in an environment where risk is often high, the margins are low, and so, of course, they're not really incentivized to innovate. There's a disconnect between the business need and the solution a lot of times. There's limited collaboration, and the owner-contractor relationship is often, it's adversarial, and it's heavily driven by the contractual terms. There's not a single point of end-to-end accountability. So you've got multiple parties involved, but the accountability is often slipping through the cracks. You've got sandbagging of the targets. You've got unreliable cost and time forecasts, and you've got overstretched owners' teams. So I'm sure, and I'm not going to spend the whole time just talking about what doesn't go well. I'm sure you've seen a lot of these. The question a little bit now is, what do you do about this? What can be done? And I'd say that the good news here is that while these issues that I've just talked about, they are prevalent in the industry, they're not actually ubiquitous. And some people are actually getting this right. And here's what we think are the 7 key traits that you'd see with those that are actually getting this right. And I'm gonna run through each of these now, and I have some further detail on a few of them that I'll share, and Tina will do a little bit as well. So the first one, ensure that you're getting the scope right on what you actually deliver. Yes, these are technical projects and they need strong engineering, but this shouldn't be left to an isolated, engineer sitting in a room by themselves that comes up with a design that then gets locked into your overall approach. You do need a robust business case. You need a strong perspective on future supply and demand, and you need a cross-functional team involved in that. You need the construction, you need ops, you need finance to make sure that what you deliver is actually fit for purpose. And if you're not developing options as you run through this process and debating the merits of each, you're probably doing it wrong. That's the first one. The second one is around setting bold targets. And the target on the project should not just be based on, well, this is what we did last time and that worked well, so that should be the target for the next one. It should be based on the full potential of the project. And I'll talk about that a little bit more in a moment. The third is around optimizing your design. Most projects do have some form of value engineering on them, but rather than incrementally starting from where you are and chipping away a little bit from the top, we'd suggest a different approach that starts from a minimum technical solution and then justifies in from there. Again, I'll talk about that one a little bit more later. There's a fourth one that's really important in the procurement area, and that's around partnerships. And we're seeing it, you're probably seeing it as well. There's really a shift away from the old style lump sum turnkey contracting model, where contractors are increasingly not willing to do that. They're not willing to take the risk. Owners are finding that when you have this model, you think you've passed off all the risk, but when things go wrong, that risk often comes back to you anyway. And everyone really spends a lot of time protecting their adversarial kind of commercial positions rather than trying to deliver the project. So you need to consider different ways of contracting, and there's various implications of that, but I think one common factor is that you need a really highly involved and proactive owners team to really drive that forward. The fifth element on here is around what we'd say shifting from defense to offense in how you deliver projects. There's a few sub-elements of that. One, and I think the bedrock of all of that is having a reliable reporting on project progress. So you're moving away from what you often see of multiple sources of truth, anecdotal examples of improvement, and a bit of a bias to optimism, to a setup where you have a single source of truth on overall projects, but you also have very granular KPIs on key productivity areas. So, for example, you might have a conversation, if you have the right KPIs, that says, well, why does the S-curve actually show that we're tracking okay, but we're supposed to be installing 20 pipe stands per shift, and in the last few shifts we've been installing 5. Something must be a little bit amiss. What are we going to actually do to get that back on track? Second subpoint, still within this delivery, is where you really start to make the shift from defense to offense, and using that data is developing a set of acceleration and cost-saving initiatives. So develop the ideas, record them, ensure that they've got granular milestones outlining who does what and when, and then track that relentlessly. And the third sub-area within that is really about starting, how do you get that to stick? How do you lock that in by formalizing some of these value-driving practices in a governance process, and having individual stage gates where you say, to get beyond this stage gate, these are the things that need to be done. And you start to then, and what you need to have is an investment committee, and an investment committee that's not just managing process on this, but that's having the sorts of conversations to say, well, show me the options that you considered on the scope, and let's debate some of that. Let's talk about some of the design items that you added back on top of your minimum technical solution. Let's review how you're tracking on your regular milestones. There's a whole bunch on the fifth one, because I'm not going to talk about that anymore later. The sixth and the sets, Tino's going to talk quite a bit about the sixth, and I'll come back to the seventh, but let's get into a little bit more detail on each of them. And I'll start with the second practice on setting ambitious targets. And on this, Tesla is actually a great example of doing this. And they call it their curve of insanity. And this was their ever increasing target that they set to get the next plant and ensure that it's going to be faster and cheaper than the previous one. And it was, and it worked. And that's what you can see on the left-hand side of this page. And this is partially driven by culture, by ambition, and by capability. But the other slightly more tangible element of this is having an anchoring in the full potential. And one of the ways that Tesla does this is they go right back to unit rates for everything, and they look at what things should cost. So, for example, if they're looking at a steel quote for something, they will go all the way back to what's the fundamental iron ore cost, and then they'll disintermediate the supply chain if they don't think they're getting to the right answer on that. Next one is on minimum technical solution. I've got a couple of slides to talk about this because I think this is an important one. What you see on the top of the page is some of the traditional approaches, and I referenced that before. And that's where you have a traditional design. There's often a fair bit of gold plating that's baked into that. And then in that traditional value engineering approach, you take an incremental exercise and sort of chip away at that. What we find gives significantly better results is you flip this process around, basically, and you start with a bare bones minimum technical solution. You then make a series of deliberate decisions to selectively add back scope that you want into it, and you have a bit this mindset that I was referencing before of you need to justify things in rather than justifying them out. And just flipping that order, that mindset, and that approach leads to some fundamentally different results, and we'd show that it leads to 2.7 times better outcomes. A few different ways on how you can do this. There's an element of modularizing and standardizing design. There's the concept of having a blueprint for your designs for future repeatability. As much as possible, every plant that you have really shouldn't be a sort of a snowflake of individuality. You need to create a solid reference design for the future. And then there's also a strong case for utilizing technology in doing this, and things like digital twins. And I'll just give you a little bit of a quick example of that. So this is one situation that used advanced analytics to optimize the thermal component of what was an off-grid energy storage system. And typically what you'd see in this sort of process in a fluid dynamic CFD model is that that these models are massive. They're extremely large, they're complicated, and they take a huge amount of computing power and several hours to even run. So what people have been starting to do recently, and what this project did, is they developed something called a deep learning surrogate. And what that is it doesn't use the full thermodynamic equations. It actually uses a close approximation of that, and can get to a similar level of accuracy, but can run much more quickly. So you can run in sort of seconds rather than hours. And so you can run thousands of simulations, and that's what was done in this situation. And you can improve both the design and then also the operating parameters. The last thing I just want to talk about on this minimum technical solution front, and the other key idea is, in going back a little bit back to this green theme, is that when the technology is new, there's often a lot of value in taking a more proactive and almost a little bit more of a vertically integrated role in the supply chain, and ensuring that there's collaboration between the design and construction and also the supply chain and the manufacturing element of it, and actually oftentimes working with OEMs in order to do this. So the case example here that illustrates a little bit of that, this is of an OEM in the hydrogen electrolyzer space. They had a compelling design, but they saw the opportunity to work with engineering firms, to work with contract manufacturers, to work with the supply chain, and in this case to bring down cost by 45%. And they did that by implementing some of these elements that I've spoken about on design for manufacturability, by incorporating modularity in the design, and designing with the supply chain in mind. And why is that relevant to, I don't think there's probably too many hydrogen electrolyzer OEMs in the room at the moment, but why is that relevant to you? I think that, there's a lot of value in doing this with new technologies. And in this case, the OEM was sufficiently proactive to do this, but in other instances, they might not be, and that might fall on you to lead this sort of process. Just want to go on to the next practice here, which is around procurement and how to deliver that in partnerships. I spoke a little bit about moving away from reliance on a contractually based lump sum operating model, and with the lead contractor. And I think one of the results of that is you get to the second concept, which is what's on this page. And that's that really that the owner needs to take a more proactive approach to things. You look at the left-hand side of this page, there aren't too many situations where it's going to be appropriate or optimal to really just be reliant on the EPC. More often than not, you want to be in the middle box on this page and a bit more of an EPC steerer, where the owner's team has the internal capability to guide the process and really push back where that's helpful. The last one that I just want to talk about on the 7 key elements is around culture. And again, I'll use Tesla as an example of this. And frankly, it's not that they're getting everything right in the culture space, but I think there are some very powerful and distinctive elements that they have that are worth calling out. The first, and we've talked about it a little bit, is setting a very high ambition with strong performance improvement and the sense that really that nothing's impossible. The second is around moving quickly, and just a little bit of a story from one of our now colleagues who previously had worked at Tesla as a construction director, and he was working in China at the time. He gets a call from right at the top at Tesla saying, "We've bought a site in Texas. We need you to come back immediately. We want the site cleared, and in 1 week, we want to start construction." So these are the sorts of time frames that they're moving on. And you can see a few of the other examples on the page. 15-minute decisions, maximum 48 hours. There's really a big emphasis on speed. The other is how they think about the owner's team. They've been very effective with a small, highly capable SWAT team that goes from plant to plant, driving the next level of improvement and learning as they go. And the last thing about the culture is just this sense and this rule that they have that no is not an answer. Not acceptable to just say, no, this is impossible, we can't do it. It's very much a can-do culture. And if you do make a mistake, there's a sense that how do you learn from that and move on. I'll hand over to Tino now to talk a little bit about the technology.
Yeah, hi everyone. My name is Tino. I'm leading the resources sector here in Australia. I'm bringing a mining example, and then I'm wrapping us up for our presentation. So on the notion of AI, using AI to innovate the way we design and deliver projects, Bevan talked about an example of a digital twin to optimize design. Another example of AI in CapEx is generative scheduling. That's right. Generative scheduling has been one of the most hottest topic in AI globally. In fact, this year was supported 3 miners in Australia using generative scheduling along the value chain, from accelerating project solar farms, port infrastructure, building new mines, to accelerate construction schedules and decreasing costs. What's the idea? So today, most of you will know, you will have a pretty linear, I would say, manual, top-down approach of how we develop schedules. We're using P6. We're starting from the level 0, what's the project scope, increasingly breaking it down to a level 3, where we have all of the construction activities, fixed inputs on productivities, labors, often used from previous projects. What we end up with is one single project schedule with one execution path. With AI, it's the opposite. It's bottom-up, it's dynamic, it's flexible. And it's basically 3 steps, which you see here. Step number 1 is building the model. Not only the physical model, but linking all of the activities together, and most importantly is parameterizing it. Parameterizing it all of the inputs that are required, from the constraints to the labor, equipment, and so forth. Parameterizing it, that to keep it flexible later on when we run the optimization scenario. So that's a big shift, not fixed inputs, but parameterizing it. In level 2, what's happening is the optimization. The first step is, I'm calling it playing Tetris. So optimizing under the given constraint and assumptions, and really kind of squeezing and optimizing the project schedules. But where the real juice and insights comes out from are the what-if scenarios. What if we increase the crew size? What if we release the constraints on our camps? What if we increase or decrease productivity? It really helps to run multiple hundred thousands, millions of scenarios to find the optimal set schedule. And then you see on the right hand, you basically have a whole cloud of different scenarios and different project schedules. You're starting from the top right, which is the base case, and you can move to the lower left corner of the chart where you have less costs and an optimized schedule. That's in the nutshell the approach. A very tangible example from the mining industry is we did this for a lithium processing mine. And you can see here the different levers and scenarios that we look for. The mix of crews, productivity, equipment rates, and so forth. And you see by far the one lever that really outsides all of them is adding a night shift. That might not be possible, that might be too expensive, but that's the fact base that you get from it. And you can ideate around this and optimize your project schedules in hours and days, not in weeks and months. So what it gives you is, it's not replacing P6, it's augmenting it. I think that's an important concept to understand. And it becomes your optimization engine. You can use it in the design phase. We've used it to support an FID. It could also be used in the actual execution stage. Imagine something goes wrong tomorrow, you can quickly run new optimization schedules. So very exciting capability. We could talk for hours for that, but I know the time is pressing. But that's another example of AI in capital projects in mining, where we have seen a lot of tractions around the globe, not only mining, but also in oil and gas and other heavy asset industries. Zooming out, the takeaways from the presentation today. Number one is we are approaching a huge wave of capital projects. Double the amount of capital spend that we had in the last 10 years is coming towards us in the next 10 years. And given the kind of sluggish productivity rate in construction, we really need to innovate how we deliver projects. Number two is, there were probably a lot of concepts that you have seen before, but our call to action is more excellence in how we define the business scope, the curves of insanity, the minimal technical solutions, all of that. They are still true, these levers, but more important than ever before. But that alone will not be enough. We need more innovation. And the two big themes are collaboration and partnerships. This is increasingly becoming a team sport. And AI. AI is not a choice anymore. It is the norm in how we design and deliver projects. Thanks everyone for listening.